All right, we're going to do a quick introduction here. Why is it we have to use rotational motion now and we haven't before? Pretty much everything we did up through the end of the momentum section where we started to introduce the idea of center of mass. We'd been dealing with everything as though it was just a bunch of point masses, just these tiny little masses flying through space. If something is a point mass, it doesn't have any width or any height or any depth to it. It has no real size. And that means it doesn't really have any meaning for it to be rotating in any way at all. But now that we're starting to deal with objects that have this extended size to them, how they move through space can be a little bit different. A calculator that's flying at you this way is different than a calculator flying at you that way. It looks different, it is different. The physics of how it moves could be different, especially if you have air resistance, because very wide resistance to the air, right? Big area versus really, really tiny area. So we have to start seriously considering the shape of the object. And that means we now have 6 degrees of freedom for an object in a three-dimensional space. So you imagine you have the x-axis along your thumb, the y-axis along your index finger, and then the z-axis along your middle finger, something following the right-hand rule like this. Then the object could be translating along the x direction, translating along the y direction, translating along the z direction, or it could be rotating around the z direction, rotating around the x direction, or let me see, rotating around the y direction. So there are now a total of 6 degrees of freedom, 3 translational, 3 rotational. Now we're not going to get into 3 rotational axes. We're just going to worry about, okay, we've got motion in the xy plane and then rotations around z. So we're really only going to worry about rotation around one of those 3 possible axes. Things can get very, very interesting and very difficult very quickly. There's a reason why we're going to step away and not yet deal with all 3 of them. It is entirely possible for you as a scientist or an engineer to functionally spend your entire career just worrying about how some kind of object that is flexible can move through a 3-dimensional space, and rotations, translations, flapping of the wings, all sorts of motions that could happen. All right, so that's sort of an introduction about the why do we care, and next up we're actually going to get into some definitions, starting off first with definition of angular position, angular velocity, and angular acceleration, as well as how they relate to one another.